So this both the method is coming under the iterative method. So this is the basic idea of this method, means Jacobi, Gauss, Seidel, even SOR. So here we need to solve the system Ax equal to B. So in terms of the equations, suppose this is the system of A is n cross n matrix, total n equations and n unknown, and definitely system has a unique solution, then only we are doing these numerical things. If system doesn't have solution or it has infinitely many solutions, so this method will not apply, cannot do like this. So whatever written here, this Aij xj equal to Bi, this is individual equations like from I equal to 1 to n. So each equation you can write in terms of the summation. And from this summation, if you expand into the like j from I equal to 1 to I minus 1, then this I term, and then I plus 1 to n, the same equation can be written in this form. So this is for each individual equation in the system. That's why for I 1 to n. And from here we can find xi. So the formula for xi will be 1 upon aii bi minus summation from 1 to I minus 1, this summation, and then minus I plus 1 to n. So can anyone tell what is the difference between Jacobi and Gauss-Seidel? So this is the
Sir,
solution. Yes.
Sir, in Jacobi method, we have a initial value, initial set given of x, and rather than changing at each step, we take it as collectively. Whether in Gauss Seidel, when we change one values, let's say x1, then when we are guessing x2, then we take the new value of x1, and similarly as for as many variables we have, we continue this process.
Okay. So anyone have doubt what is the difference between Jacobi and Gauss-Seidel? Please tell me. I will repeat. If you have doubt, what is the difference between Jacobi and Gauss-Seidel? The formula for both is the same. Anyone, if you have doubt, tell me. I will explain.
Yes, sir. Please repeat.
Okay. So suppose this is n cross n matrix A, then how many unknowns in X? Total how many unknowns?
N unknowns.
N unknowns. So here in this we are calling it is x1, x2 up to xn. Okay. So these are iterative methods. So we'll start our initial guess, like what will be the solution. You can guess any solution, like x1 equal to suppose 100, x2 equal to 5, because you are solving. So first you have to take an initial guess, like you are taking initial guess in Newton-Raphson method. So first you have to guess something, like what can be the solution. You can guess anything. You can guess 0, 0 is the solution. So once you will guess the solution, then you will put that solution in this formula, because here x is also present in this formula. So xi in terms of remaining x, like xi is here, then remaining x means from x1 to I minus 1, I is not present, then I plus 1 to n, all x are there. So those x, whatever you guess, this is the solution that you will put here, and you will get a new value of, like you will get a new value of x1. If I equal to 2 in this formula, you will get a new value of xt, x2, and so on. You will get a new value of xn. So this is called step 1. Step 1 is finished. So initially you started with some random guess, whatever you expect, you can take that guess for this system of equation Ax equal to B. By using that, you got a new solution by using this formula. Once you will get a new solution, that is step 1. Step 1 is completed. Now if you do for step 2, then you have to repeat the same thing, but instead of that random guess, whatever new value you got, those value you have to put here and again find a new value of x1, x2 and xn. This is called Jacobi method. So that method is clear. You can take any guess, put in the formula, find a new value. Again, whatever new value you got, same value again you will put here in this formula, you will get again a new value, updated value, and so on. Is that clear for everyone? So anyone have doubt, tell me.
No doubt, sir.
So this is Jacobi method. Now we'll come to the Gauss Seidel. What is the difference between Jacobi and Gauss Seidel? Suppose we are calculating x1, right? Then x2 in Jacobi. What we are taking x1, x2, x up to xn a guess. After that we are getting a new value of x1, x2, xn. Then again those new value you will put, again you will get a new value of x1, x2, xn. But in Gauss Seidel what we are doing, once we will get the value like x1 we got, we can use that value to find x2. Once you will get x1 and x2 both, that both value x1 and x2 we can use for finding in x3. But the same thing we cannot do in the Jacobi. That is the difference. Like if you got x1, x2, x3, x4, so in order to find x5, x6 and so on, you can use the previous value whatever you got. That is the main difference between Jacobi and Gauss Seidel. Like once you have latest value, you have to use that latest value in order to find the next value of x. That is the difference between Jacobi and Gauss Seidel. Suppose there are only 3 cross 3 equation, system of 3 cross 3. A is a 3 cross 3, then you have only 3 unknown, x1, x2, x3. Suppose you assume initial guess all are 0, x1 is 0, x2 is 0, x3 is 0. Then you will use this formula, you will find x1. Then instead of x2 and x3 you will put 0 here and you will get x1. Once you will get x1, then you have to find x2. But if you find x2 by using this formula, then x1 value you will not take a 0. Whatever new value you got, the same value you have to use for x2. Once you will get x1, x2, for x3 you have to use x1 and x2 the latest value. So this is the difference between Jacobi and Gauss Seidel. So anyone have doubt what is the difference between Jacobi and Gauss Seidel? The only difference is that whenever you will get the latest value, use that value in order to calculate the next value of x. But in Jacobi, what we will do, first we will find the latest value of x1, x2, x3, xn, all you will get by using the previous value. Once you will get all value, then you can go to the next step. But here in between the step, you can update the value. So which method is good, Jacobi or Gauss Seidel?
Gauss Seidel.
Gauss Seidel, why?
So because it is an update of Jacobi. It takes the latest value, so it tends to be more accurate, na?
No.
Mm.
Yeah, anyone want to say anything?
Sir, it's a faster method than Jacobi.
Yeah, faster we can say, but not we can say accurate. Okay, so we are doing like we got one updated value, then again next updated value and so on. So when we will stop? When we will think that our solution is very close to the actual solution, we will stop. Like we are stopping in bisection, Newton Raphson. So when we will think that okay, now we got very close to the actual solution, we will stop. So what will be the stopping criteria? When you will feel okay, we have to stop.
So some tolerance limit.
Tolerance limit. Suppose solution is x1 is 1, x2 is 2 and x3 is 3. Suppose 1, 2, 3 is the solution. Okay. And you are doing Jacobi iteration method. So x2 came 2, exactly 2, x3 came exactly 3, but x1 is coming 100. So will you stop or not? So where you will use the tolerance? Like out of n, suppose some value is very close to that, and but some value is very far to the solution. So what you will perform the iteration or not?
We will take the norm. If norm is very less closer, then we will take the solution.
So what is the norm? Say someone said some word norm. So can you tell me what is the norm?
Hello.
Yes. Yes, someone want to say, please tell. Can anyone tell when we will think that okay, now our solution is very close to the actual solution, we will stop? Someone said norm. So I am asking what is norm? Yes, anyone tell who told norm, please tell me what is the norm. And if you are saying some norm, then how will find the norm? So when we'll say number is close to the another number.
Hello.
So when
Hello,
distance
sir.
between
Yes, distance between.
the two numbers is less than some for any epsilon, say,
Yes.
if we
So
can make them less than.
yes. So if you see in real number, like we already seen, the sequence will converge to someone. Xn minus x is mod of that is less than epsilon. So that mod is the distance of xn with x. Like sequence is converging. In case of Newton Raphson, even bisection, we have one solution, means we are taking one guess and we are slowly going to close to the actual solution there. But here the situation is different. Here we have one vector, that solution x. It has some n component, x1, x2, x3 and xn. So that sequence of a vector, not a one number, whole sequence will goes to the actual solution. That means the sequence of vector must converge to the actual x. So what is the condition or what is the criteria when you say that the sequence of vector will converge to the actual solution? So we need a distance between two vectors, and if that distance is less than tolerance, we will stop. So like in R we have some distance. So can anyone tell how to find the distance of two vectors? Do you know any
Yes, sir.
formula?
By calculating the norm,
Can you tell me the formula how to find the
like
distance?
root under square of all differences of the corresponding
Okay, fine.
coordinates, first coordinate,
Yes,
second one.
so that formula we can do. We can do the square root and then difference between the two coordinate and then whole square. That formula x1 is minus x2 whole square plus y1 minus y2 whole square plus so on y. Similarly, xn minus yn whole square, then whole square root. So that is one way to do the distance. But there are other distance also, measure of the distance. So that also if you do, then also you will get the correct answer. So what I will use, if suppose you will take the difference between the two vectors, and if maximum value, whatever the maximum value, that element is less than epsilon, that means remaining entry will definitely less than epsilon. Is it okay? Suppose actual solution is something, you got some solution, take the difference and find which one is the maximum. Like x1 is maximum, x2 is the maximum, x3. If maximum is less than epsilon, that means the remaining entry will definitely less than epsilon or less than tolerance. So I will use that criteria. You can use even this Euclidean norm, whatever you are saying norm. There are other norms. So I will use the maximum norm, that sup norm, or the distance, maximum distance if less than epsilon, then we will take the that criteria. So the only thing we have to do this one, this formula, if you are able to implement, that means Jacobi is done. So tell me which one you want, Jacobi or Gauss Seidel. I will do only one, remaining you have to do. I will do complete Jacobi or Gauss Seidel. Tell me which one.
Sir, Gauss Seidel.
So other people, you want Jacobi or Gauss Seidel? If you say Gauss Seidel, I will do Gauss Seidel, no problem. Okay, I will do Gauss Seidel. The easiest one you asked, Gauss Seidel. Very easy to do. So this is the algorithm anyway I will share to you. So this is the criteria that distance is less than this tolerance. That distance norm I put here. You can take maximum norm, you can take the square root formula, any distance formula you can use in order to get this tolerance criteria. So this problem, this is the solution is given. I will solve. First I will solve by this linear algebra command. So tell me how to write the matrix here. So one more thing is that if you take any initial guess, will it always give the correct answer, that Jacobi method, or is there any restriction? Only those condition will satisfy, then only Jacobi method will give the correct answer. Or for any matrix we can apply, we'll get the answer. That already I think
Sir,
discussed. That's
some
why.
condition is there. What the diagonal elements, something like that.
Yeah, so
Dom-
matrix should be diagonal dominant, or
diagonal.
the norm of the matrix is less than 1, or the maximum eigenvalue is less than 1. Any criteria means you can apply. So the diagonal dominant is easy to see from this. This 7 is the diagonal entry is bigger than the sum of the remaining entry in the matrix. So here it is diagonal dominant. Here if you say 0, 8, 0, sorry, 1, 8, 0 and -2, so definitely 8 is bigger than the remaining sum. Here also 4 is bigger than the remaining sum, and the 6 is also bigger than the remaining sum. This 2, -2 and thus -1. So put the mod, do the sum, it is less than 6. So this matrix is diagonal dominant. So if you solve by Gauss Seidel, Jacobi or SOR, it will definitely converge to the actual answer. That means you will get the solution after certain iteration. So first I will tell me how to write this matrix in Python.
First, we import the library NumPy, then we can write the name of the matrix, that is A is equal to np.array. Within
Okay. Let me write this much. So I am going to implement Gauss Seidel method, not Jacobi. Jacobi you have to do yourself. So I am creating a new file. So I think it is visible to everyone.
Yes, sir.
Yes, sir.
So import numpy as np. Then I want to declare the matrix A by using np.array. And in this bracket I will write the all 4 row. So the first row 7, 1, -1 and 2. 7, 1, -1 and 2. This is the first row. Then second row is 1, 8, 0 and -2. 1, 8, 0 and -2. Then goes third row, -1, 0, 4 and -1. So if matrix is not diagonal dominant, and if you can make a diagonal dominant, suppose this equation number 1 written at the last and the last equation written on the first, then you can interchange the row and then start writing in the Python. Like suppose this equation came on the top and this top equation in the bottom, then you have to interchange the row and then start writing like we are writing now. If it is not diagonal dominant, then you have to make. If you can make, if you are not able to make, then you have to use other criteria. So the third row is -1, 0, 4 and -1. -1, 0, 4 and -1. And then the last row 2, 2, -2 and -1 and 6. So till now I did nothing. I just wrote a matrix A. Now I am going to write the matrix B. Right hand side.
Sir, in A, one more square bracket will be there.
Oh, the matrix 1. Then 3, -5, 4 and -3. 3, -5, 4 and -3. So this how to find x, what to write?
np dot
Yes, can anyone tell how to
np dot
np
arrange
dot
for
linear algebra solve AB.
linalg dot solve a comma b. I'm going to print x. Let us see. So it is giving the correct answer 1 minus 1 1 and minus 1 whatever written here. We'll do the so what we have to do, we have to write this formula only. Once you will able to write this formula, then so this xi we have to write for I1 to n. 1 to n in the actual matrix, but in Python it will start from 0 to n. So first I will write this, then for summation, you know, you have to use the for loop. For this summation also you have to use the, then this bi and then divided by aii. So here I am going to write Gauss Seidel. So I'm just copying A and B. So what is the matrix? That means n value 4 unknown, or you can write the length of B or the shape of A. And so now tell me what to write for that formula. So I want to write
we
this
have
formula.
to define
Yes.
define
Tell
an
me.
array X.
Okay, so first I will define the X, that initial guess. So tell me what initial guess you want.
All entries 0.
So I am writing like this. You can even use zeros command also. np.array. So all entry 0, this is the initial guess. This is the solution, I assume. You can write 1, 2, 3, 4. I will change later and I will show. So I assume this is the solution. That is the initial solution. This is the guess. So here I am writing this is the guess. Initial guess. Then we have to write for I from 1 to n this formula. So this is 1 to n, but in Python we will write 0 to n. So for I in range, so what to write here?
Small bracket of n.
Yes, so this is done. 1 to n, it is done. Now I will write this. So how to write these summations? J from 1 to I minus 1 and then I plus 1 to n. Both summation and then bi and then divided by ai will get xi. Xi is the solution. So how to do the summation in Python?
Master, define sum is equals to 0.
Okay, so I will define sum equal to 0. Okay, next.
So for j in range,
Or j in range. So here you can see j from 1 to I minus 1, then I plus 1 to n. J is running from 1 to n, but actually it is 0 to n minus 1. So this summation we have to do, then subtract from bi divided by aii, you will get the solution xi. So tell me what to write.
For range n,
Range n.
and then we will take j is not equal if j is not equal to I.
If j is not equal to I, so how to write not equal to?
Equal to and then exclamation mark. No, sorry, exclamation and then equal to.
J is not equal to I. Then we have to do the summation. Sum equal to
Sum
plus
plus
and then
xi
aij into xj.
xj.
This is in the summation. So ai comma j into xj. Done. So once the summation, this j loop is over, that means we got the sum. Then what is the value of xi? Xi will be 1 upon aii bi minus this sum. So I will write xi. This is outside this loop. This whole loop is for summation. That is done. You can do two loop, like you can write j from 0 to I minus 1 summation, like sum 1. Then you can write sum 2 from I plus 1 to n minus 1. This is sum 1, this is sum 2. Then xi will be 1 upon ai bi minus sum 1 minus sum 2. That also you can do. But here I am doing in like this only. So bi minus this sum, whatever it will come, divided by ai comma I. So this is only one step. Like we started with the initial guess 0 0, and within one step we got new x. Let me print this new x. So after putting 0 0 in that formula, what value of x you will get? Let us see. Is giving what? So it will give 0 0 1 0. So this is step 1. Suppose you want to perform 10 steps, then what to do? Suppose the same thing you want to repeat 10 times.
Sir, we will apply while loop with the error condition.
Yeah, so I will do error condition later. So suppose I want to perform only 10 iteration. So I'm writing k. I will do that while loop also. Suppose 10 times, like 0 to 9. The same thing it will repeat. And this is also inside this. So k 0, then 1 times it will give 1x. The next step again it will go up because it is Gauss Seidel. So whatever latest value will come, it will automatically go here in place of x. And we'll get a new x. So now I'm running. So see, it is giving, it is not updating anything. So the reason why, because here all are integer divided by integer is integer. So what change I have to do? These all numbers are integer.
Dot 0.
Any one we can make it float, or we can define any data type also float in order to avoid this thing. So it is still giving this one. So which one is it doing, I don't know. So I will completely define the data type float. Float 64. That means all entry are in the decimal. That means this is not 3, this is 3.0, 5 minus 5 is minus 5.0, and so on. So we got this one. That means our value is not updating. So can anyone tell what is the reason and where I did mistake? I simply wrote that formula, whatever you told. After that I got this one. and then it is not giving the correct answer. So let us change the initial guess also and see what will happen. Suppose I took 1 2 comma 0 0, and if I am running, I am getting the again the same. So let me change completely 9 and this one 10. I will refresh. So now it is change something, and again it will give me 1 0 0 0.
Sir,
Yes.
for j in range n, if j not equals to I, then
Yes.
for I, when I equals to 1, then it not take the value of j equals to 1, because j not equals to I.
Yeah, j is not equal to I. So if you calculate x0, it will not take 0. If you calculate x1, it will not take 1. If you calculate xn minus 1, it will not take xn minus 1. So there is no problem. Right? Yeah, anyone want to say something? Then I will do something. First tell something. Till now I didn't use any norm, error, less than epsilon, tolerance. Only 10 times I am performing and I am getting this one. So in the first step, it is giving minus 1, 2, 3, 1. Then it is giving this one. That means for next iteration, it is not changing, it is giving the same thing. So is there any problem in this code? So I will restart and I will again run. So 1 minute, so I have to import the library again. So it is giving this one, same. So can anyone tell what is the problem in this code? Or it is giving the correct? Yes.
In
Yes.
formula.
What? In formula, what happened?
One term is missing, I think.
Which term? So I exactly copied the formula, this one, this sum, and this sum I am calling it is whole sum. J from 1 to I minus 1. So we started from J0 and it will go up to N minus 1. Then subtract from BI and divide by AII, you will get XI. The exactly same thing we are doing. But it is not giving the correct answer. See what happened, it is giving this 0 0 1 0, and once you will put in this equation again, you will get the same. So every time it is repeating this for this value. Okay, so now what we'll do, I will not tell anything for the timing. We'll do this for some other problem. Okay, we'll change the matrix A and B. So let us see it is working for some other type of matrix or not. Like not this system, some other system. So I'm just taking here. So whatever I gave the problem in the assignment, the same problem I will try. So you just open the assignment and tell me what the entry I have to write for matrix A and matrix B. So this is the assignment. This is equation 1, 2, 3, 4. So tell me what entry I have to write in order to solve this by Gauss Seidel. So what will be the first row? Can anyone tell?
One, 4 minus 1, 1.
4 minus
No, that is not the correct answer. The first row I am asking.
4 1 4 1 minus
1
1
minus 1 1.
1 minus 1.
So this one is the first row, right? Because it is diagonal dominant in the A11 entry. This is the diagonal dominant in A22 entry. So it will go in the second row. It will go in the third row. This one will go in the fourth row. So tell me, I will write here 4, 1 minus 1 and 1. And right hand side is minus 2. So I wrote this equation 4, 1, minus 1 and 1. Right hand side is minus 2. So now which one will be the next equation?
First equation.
Yeah, first equation 1, 4. This one I will write here minus 1, and last one is also minus 1. So 1, 4 and remaining all are minus 1. And right hand side is also minus 1. Then this one will go in the third equation because it is diagonal dominant. Right hand side is 0, minus 1, minus 1, 5 plus 1, and right hand side is 0. Then we will write the last equation. Last equation is 1 minus 1, 1, 3, 1. 1 minus 1, 1, 3, and 1. So now I'm running this one by using this, and let us see what we are getting. We are getting something like this. So first we will see what is the actual answer. That means something is really wrong in this code. That's why it is giving this type of wrong answer. So I will solve this by linear algebra command, like we solve here, and we will get the correct answer. So this is the correct answer. So I tested the same method for both the problem, this one, and both time I am getting the wrong answer. So definitely something is wrong. So who will tell the reason? So now I'm taking all the guess 0 in this problem also. 0 job size n. And now I'm running. So now tell me what is the, I did the correct things, means what is the correct solution I did, but I want the reason from you. What was wrong actually? See, what I did, I changed the x 0, 0, 0, and see this is the first iteration. This is the solution x1, x2, x3, x4, and in the 10th iteration this is the solution. And if you match this solution with the this one, so you will get the same thing. By linear algebra solve command, I got x1, x2, x3, x4, and within 10 iteration by Gauss Seidel we are getting almost same thing. So now can you tell me what was the wrong? At least now you will able to answer.
So the earlier system of equations was not diagonal dominant.
This one. Okay. Let me change here also. The initial guess is only 0. So this is the earlier system, and we are getting, this is very close to 1, minus 1, 1 and 1. Exact answer, whatever we are getting. So it is also getting the same answer. So this is actually diagonal dominant, this 1, then mod of minus 1, mod of 2, it is less than 7, it is diagonal dominant. Here also mod of 1, mod of 0 and mod of minus 2 is less than mod of 8. So all are diagonal dominant. So now I am getting answer also, exact answer. So now can you tell me, I already saw what was the error. Okay, I am leaving this to you. I will not tell now answer. So here I took the initial guess 0, 0. The same formula I applied from here to here. This is the formula. And the same step I am repeating 10 times. That's why this for loop k is running from 0 to 9. That means 10 times. And we are getting answer in 10 iteration. But now what I want some tolerance. When it will meet that criteria, it will stop.
So the way you defined X, is that making any difference?
Yes, so that you have to tell, means you have to do experiment and then you will able to know the answer anyway. I told what was the mistake. If you do it, automatic it will come, no problem. You will able to get anyway. So now I want to perform this whole formula until unless I will not get our solution close to this tolerance criteria. So tell me what tolerance you want. I will use that tolerance. Tell me what tolerance you want. I will use that tolerance.
10 to the power minus 5.
10 to the power minus 5. So whenever the difference or norm or maximum error is less than that, then only will stop, otherwise we will run this code. So here I have to give this loop. I will give while. Tell me what to write. I have to first find the norm. So I will tell first how to find the norm in Python. There is a already linear algebra command which will give the norm. So here I will show the suppose x is this one vector. So give me some entry of x, some 4 cross 1 vector.
4 to 1, 4 to 1,
4 comma 2 comma 1. One more entry.
0.
0. Now I am assuming one y also. Give me some entry, random entry.
1, 2, 3, 4.
1 comma 2 comma 3 comma 4. So if you take the difference x minus y, so what are the entry of x minus y?
3, 0.
Okay, I will just print x
3,
minus y.
0.
Print x minus y. It will give 3, 0, minus 2 and minus 4. So which one is the maximum modulus out of this 4 entry? Which mod is the maximum?
4.
4. So if that modulus is less than epsilon, that means remaining entry will definitely less than epsilon.
Yes, sir.
So we have to find the maximum modulus of this. So first I will use the absolute value ABS, that will give the absolute of x minus y. So this will give the absolute value, that means this one, and now we have to find the maximum. So tell me how to find the maximum of this. So that I will get the answer
Max.
4. So I will apply the max. Let us see what will come. Maximum of absolute value of this one. So it is giving 4. So this criteria I will apply. If the maximum is less than epsilon, that means remaining entry will definitely less than epsilon. That means all are close to the actual answer. So is that clear? Now I am going to implement this in here. So now tell me what will be x, what will be y, so that we can take the difference. Like what will be the difference? Difference will be this one. This one we started with 0 0. This one is the 0 0 solution. Then we got new solution. Then difference we will take and we'll say that difference is maximum value is less than epsilon or not. If not, then we'll find this again, this next step. Then we'll take the difference this with the previous value, and then we'll check the it is less than epsilon or not. And until unless it is not less than epsilon or tolerance, we'll do the same thing. So we'll take the difference between the two consecutive iteration. So how to find these two difference here in the code? Can anyone tell? Like I want the difference of this, like each iteration will get a new value and we'll take the difference absolute value modulus and we'll check less than epsilon or not. If not, then again we'll find this and so on. We'll do up to last. If it is less than epsilon, we'll stop immediately up to that iteration. So every time we are getting new x, these are the x. So what to write here and how to find? Is there any change I have to make? Can anyone tell? So I am doing here. Suppose y is also the same. So y is 0, x is also 0. So y is 0, x is 0. Once will formula x will change or not, x will come, yes or no? Initially x was 0, y is also 0, but once you will change this, means you will apply this formula, x will come this one. So this difference with the y, and we'll take the maximum. So here I am calculating maximum of absolute value of x minus y. So this one I am calling something, this is equal to, so tell me what you want to call this. I will write the same name.
Error,
small-
E double R.
Okay, E double R. I wrote error on. So here I am writing error equal to just 1, and here I am checking error is greater than tolerance or not. If it is less than, it will stop. If it is greater than, it will run. So that error will be greater than tolerance. That means it will run. Every time we'll check the error. If it is less than, it will stop automatically. Like same whatever we did in Newton-Raphson and all.
Sir, but we are interested in calculating the difference of two consecutive now. Then y is to fix always.
Yeah, so we'll change y. So once we'll get this value, what will be the y? This is the y now.
Hmm.
This is the y, and we'll get the new x, this one.
Hmm.
So then y will become x. Like the previous whatever x we got, that will keep in the y. That means y equal to x. So now y is also changing, but it is changing with the previous value of x. This is the latest x, and that latest x I am writing in the y. Now x is changed, then again x minus y. Is it okay?
Yes, sir.
So there is a minor error is there. I will explain here also. So first let me run this one. So I run this. I got only 2 iteration. It's saying that after 2 iteration, that difference is less than tolerance, it is stopped. These are the 2 iteration. But answer is not this one. Answer is 1 minus 1 and 1. It will go at least some 4-5 steps. So where I did the mistake? In this step. So first I will explain, then so what is x equal to y in Python? Suppose x is the array. Give me any vector. Give me any vector. Some entry.
2468.
2, 4, 6, 8. Right. Now I'm printing x. Up to this, no problem. So it is giving x value nicely. Now if I will write y equal to x. So now I'm printing x just to show you, and I'm printing y also, because y equal to x, so both are giving the correct answer. Up to that, no problem. Right, even I also wrote y equal to x, so no problem, y will become x. So I'm just removing here, I'm just printing y, so y is changing here. Right, suppose I want to change this entry 4, so what to write? Suppose this x2 entry, instead of 4 I want to write 11, so what to do? X2 entry I want 11. So if I will print x, what answer it will give? Tell me what answer it will give.
21168.
So it is giving 2, 4, x2 means this entry 6.
Yes, 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 sir. Yes, sir.
So I have to write x1. So it will give 2, 11, 6, 8. So now what will be the value of y? Can you tell? Yes, what will be the value of y? I change only x entry.
So
I didn't
21168.
change
2468.
y.
21168.
2, 4, 6. See, y is giving 2, 11, 6, 8.
Yes, sir. It should give 21168.
Why? Why it should give?
Sir, because we have defined y in that way only, it will call for y. What is y? Y is equal to x, and the updated, like, last value of x is that
So,
21168.
so x I change 11 and I call y, but I'm changing x, I am not changing y. Let us do again. y1 equal to 11. Now x and y, if your logic is correct. I'm changing y, I am not changing x. What will be your answer? It will print the same thing or it will print the different thing? I will run and I will show you.
Sir, it will print x as the earlier 2468 and y will be 21168.
Let us see. See, it is giving the both same thing. It is not giving 2, 4, 6, 8 at all. So the conclusion is that change x or it will if you change y, because x equal to y or y equal to x, both. This is generally not happen in math. According to mathematics, that is wrong, but according to because Python algorithm is designed like that, so that's why it is giving the same thing. If you change automatic, is that clear?
Yes, sir.
Y equal to x means if you change anything in y, x, or if you change anything in x, y will automatically change if x equal to y. So that is happening here, but we don't want that one. Where is went? Yeah, here. So this y equal to x I wrote here, but once the x value will change, y will also change. That means xy will become same. Then the difference is always 0. It is less than tolerance. It is stop immediately. That is wrong. This y equal to x I wrote. That means up to first step it will give, but next step it will give x and y both are same. That means absolute value x minus y is 0 vector and all entry is 0. So maximum is also 0. It is definitely less than 0.01 and it is stopped. That is wrong. So in order to avoid those things, here in Python there is a command np.copy. So once you want to copy something, then you have to write this one. You cannot write y equal to x.
Sir, I
So
don't
it will,
think that was a problem because you are calculating the maximum of absolute value earlier to that y is equal to x earlier to that. Then it will always.
no, it will not give earlier because both are same. So if it is not problem, I will first show you both. So just I'm commenting this one. What is the problem? I will show you y equal to x, right? So first I am printing x and then I am printing y. So this x will be the updated x, not 0 0. Y is the updated y. So if you run this, see here both are same, because y equal to x. So each entry of x is same as y entry is same as x.
Sir, 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 but what I'm telling that you are defining y is equal to x after that error wala term.
So that's why
Yeah,
first term, that's why it is not stopping after the first iteration, it is stopping exactly after second iteration. One time it is running and next time it is stopped, because next time onward it will become.
so next time also let's just take y as the. Sir, you just. Sir, it is not a problem because you're defining error term before y is equal to x. So when it
I
will
am
run from.
defining before this, then it will take 0 as a y, but x is the updated value. It will calculate the error. Once it will
Yes, sir.
calculate the error, I am writing y equal to x. Just once you will write y equal to x, that means all entry of x will become y. Up to that, no problem. Once it will go here, changing in this, y will become x only. Then it will go to the next step, error will come 0. Let us print error.
Sir, but y is equal to x will go in the second step and then again you are calculating the new x na. This whole loop will again run
I
and
am,
then new x you will
yes, I am
get.
calculating new x, but once you are calculating new x, same time during the calculation of new x, y is also changing,
Y
because
is changing after the
no, it is not
error
changing after
calculation.
that. It is not like C programming or C++. That's why I gave the example.
Oh.
It is Python, because in the first step this is the error, in the next step it is the 0. See here, I am changing this y here, and y equal to x is written here. After that I am changing y, but it is changing here in x also, so all both are changing. So that means whatever computer memory have x equal to y, so what Python will do actually, it will specify one space memory for x. Once you will write y equal to x, it will delete one variable, the same variable it will keep there only. So once you will change there, it will change there only. So that's why both x and y are automatic same. Is that clear in terms of memory, where it will do the memory management? So if you write the command np.copy, then it will create a extra space or memory for y, so it will not overwrite the value and it will give the correct answer. So this, see, the error is this one, then error is changing, and slowly error is less than 10 to the power minus 5. It become 10 to the power minus 6 and it is stop, it will give the answer. So you can print the answer also in each iteration. So this is the end of Gauss-Seidel method. So up to this much iteration. If you want to print even iteration also, so suppose I want to count iteration, so what to do? How many iteration it took? So initially iteration was 0. Like before performing anything, I want to count the iteration. How many iteration? So what to write here? So that it will give the iteration. I want to print the iteration.
Iteration equal to
Iteration equal
iteration
to
plus
iteration
1.
plus 1.
Yes, iteration equal to iteration plus 1. So I am writing that line. ITR equal to ITR plus 1. So every time it will increase by 1. And in the last I am printing how many iterations. So total 10 iteration it took in order to get accuracy of 10 to the power minus 5. And you can see the 5 digit will exactly match in sense of rounding. Like see here, 0.999 is very close to 1, even no digit is matching. So 10 to the power minus 5 means 5 digit will match. So here no digit is matching with the 1. Here also no digit is matching with the 1. It is matching in terms of rounding. This is 8 bigger than 5. If you do rounding, it will become 10. So it is minus 1. In terms of rounding, it is exactly same 5 digit after decimal.
Sir,
Yes.
sir, that 5 digits you are telling, that is the difference between the 9th and the 10th iteration, and not with the 1 and minus 1 and 1 and minus 1.
No, see this one and this one, this one the difference, this one and this one the difference. So difference is 10 to the power minus 3. That means the digit will also the same. If digit will not same, then how the difference will come 10 to the power minus 5? The 5 digit must be same. Then only that 0 zeros will come. Then difference will be the order of 10 to the power minus 5. Yes or no?
Yes, sir.
See here 97, 99. If you take the difference will not come 10 to the power minus 2. It cannot come because it is not same. If difference will come 10 to the power minus 2 or minus 3, that means 3 digit must be same. So now this is Gauss Seidel, you have to do the Jacobi. So I am just telling the hint. In Jacobi, here you have, instead of x, you have to write y, calculate the value, then write the final x. In between you cannot update the x, but here we can update the x. That's why I didn't change x here. You have to find x1, x2, x3. In each iteration you cannot use the previous value. So previous value we can write here y, some other variable, and then you can find this tolerance and all. So now, any doubt, tell me. In Gauss Seidel, just 2 or 3 line you have to change a little bit, it will become Jacobi. So anyway, algorithm is given here. Also I wrote here, if diagonal entry is less than delta, very small diagonal entry, then it will show some message that diagonal element are very small, because if you divide by that, it may get error in the solution because of the small entry in the diagonal place, because we are dividing by this AII. If it is very small, then it can cause some error. Not always, but it can. That is happening generally if matrix is ill condition or if condition number is very high. So that algorithm anyway I implemented. I told how to do. Anyway I will share that code completely with you. So this is the Gauss Seidel you asked. So I like that also you can break in 2 parts and you can do the summation. Like sum, whatever sum will come up to that. In that sum you just add remaining thing. So you can write the same variable sum. So this is SOR method. Anyway I didn't ask SOR. This you first find Gauss Seidel solution, then use this formula to update the solution by using SOR, where W is the parameter lies between 0 to 2. So anyway, I didn't ask you, so don't worry about this SOR algorithm. So if you are in doubt, ask me. So here you have to solve. I already told you how to rearrange, and this I already did. I will share with you anyway, so you can directly copy and paste and you can submit, but that you have to do yourself. And here I ask also calculate the number of iteration in both the method. Like here Gauss Seidel is giving 10 iteration for this, not this problem, for that problem. So you have to print both the iteration also and compare how many iteration in the Gauss Seidel and how many iteration in the Jacobi method. So one more assignment I will give, that is assignment number 11. Maybe I will post tomorrow. I will give enough time to also. So here initial value problem is given, this one you have to solve by explicit method, explicit Euler method, in the domain 0 to 0.1 with this step size. This is also very simple. You have to use the only Euler formula. Then you have to plot the solution for each cases, for h equal to 0.1, this and this, and with the exact solution. The same exercise you have to repeat by using modified Euler and then RK4. So anyway, I will this you to you tomorrow. You will get enough time, at least 2 weeks for this also. Anyway, in the next lab I will explain. Next lab on 2. And 9, okay, if needed I will take, otherwise no need of lab of on 9.
Yes, yes.
So you will get a 9 December to submit this assignment. Like this one you are getting 2 up to 2. So 9 December you have to submit this also. I will post anyway this one tomorrow. So still I didn't completed your grading. I am still doing. Once it will done, I will post to you. So like that I'm getting your files like this, for example, this Gaurav. So this many assignment he submitted till now. And what are the things inside this? This is the file. So each lab contained 10 marks. If you missed or you didn't submit, so definitely you will get 0 marks corresponding to that lab. And if you submitted, then you will get some non-zero marks. Zero
Hello,
anyway
sir.
you will not get. Yes.
Sir, I am admission late.
Yeah.
So
So
in
yeah, what is
assignment
your
2,
what is your name?
Satwin Subramat.
1 minute. Tuhin.
Yes, sir. Sir, in assignment 4, I attached the assignment 2.
Yeah, I gave the time those who submit means came late
Sir,
for
you said
them.
it.
Yes, I said. So it is there, then no problem. I will check.
Okay, sir.
And I will check the last version, whatever the updated version you send, that is the version 5. If you submitted 10 times, the latest one I will consider.
Okay, sir.
Yeah, for those who join new, they missed 2 labs. So for that, the Python basic you submitted. So for that, 20 marks for that only. Like this you submitted. So I will check this one. Yeah, any other doubt if you have regarding this assignment or grading or anything, you can ask. That I initial value problem I will start in the next lab. I will take your attendance. So Uma Shankar, are you there? Uma Shankar, are you listening?